Today, we get to put all the pieces together. We're not graphing logs today, but you could, because anytime we're graphing a log, we just want to make the argument what numbers? One base and one over base, every time, every single time. Now, that was just a quick check to see. Today, we actually get to start doing the stuff that's more fun in algebra rather than just graphing and all that stuff. We get 3.4. And in 3.4, our focus is going to begin today with this lovely idea of log equations. Or just rather, solving equations is really all we're doing. Just happens to be that we're going to use these new powerful tools that we have. So we're going to look today at how do we solve equations. Excuse me. Now, as we go through here, we're not going to finish today. I'm not going to give you homework on this one. I'll just let you guys finish, although it seems like most people are close to done. So pretty chill night, I hope. When we look at these, we are going to make use of two properties. And that's like, we'll probably use more than that, but there's two really important properties that we have. And these are going to be, I'm just going to give both flavors. We have properties of one-to-one or injectiveness. Now, the one-to-one property, it shows up in both exponential stuff and it shows up in log stuff. And you may not remember it by name. Like it probably sounds familiar, but could you write it on your page if I said write the one-to-one property from memory? Probably not. Some of you could, maybe. I can, but I'm your teacher, so that makes sense. I bet you can finish it, though. A to the x equals a to the y if and only if what is true? Okay, that is a one-to-one property. And it's obvious the second we write it. I'm going to change color here just so that I can differentiate in mine. If you just need, I don't want to put a dash because it looks like it. There's one of them. The other one, what if I say that log base a of x is equal to log base a of y? That's true if and only if what? Hey, it's the same thing. For any y value you give me, there's exactly one x that matches. For every one y, there's one x. That's why it's called one-to-one. Okay, so we have these properties. And we're just going to jump in. We're going to do two more properties. Not only do we have the one-to-oneness, and I guess because we have one-to-oneness, and Dolan already answered this one earlier, so anybody but Dolan, why do I care that logs and exponentials are both one-to-one? The inverses exist, and it turns out that they're inverses of each other. So we saw this on the assignment with one of the problems that we worked through, but we're just going to make sure that we have the inverse properties available to ourselves as well. Okay, now these, again, they show up in both of them, but if I were to take the natural log of a to the x, what does it give me? Whoa, I need to change this. The natural log of e to the x. I'm so sorry. X. Now, this is the variant where we have the natural log. What if I said log base b of b to the x? It's still x. It doesn't matter as long as the log base and the exponential base are the same. ln works nicely with e. Log base b, whatever b is, works nicely with b. Okay. Now, this property is true, and there's nothing crazy. If you looked all the way back at your notes, when we checked to whether or not stuff was inverses, you just checked that f composed with g was x. This is what the composition looks like, and it is x, so they are inverses. Now, the other side of this is less intuitive for me, but I hope that's not the case with you. On the other side of things, this is using the natural log of an exponential, but we could also switch the direction. What if I take the exponential with a base e of a natural log? Gut feeling? X. They undo each other just like they would here. Now, it doesn't really matter if it's e. ln x gets used pretty much all the time if I have the opportunity because it's less writing, but we could do it with anything. B to the power of x, just kidding, b to the power of log base b of x. It's an awful looking exponent, but do I have an exponential and a log with the same base? So what do you think this is going to give me? This is our key to so many different types of problems. Now, the fact that logs undo exponentials and vice versa are going to be crazy, crazy helpful for me. Now, we did a bunch of simple equations throughout. We've done the one-to-one property. If we need to do more, we will, but I'm going to try for now to just get to the more interesting questions. The questions that I'm talking about, I'm skipping. I'm just going to put them up on the board. And I just want you guys to confirm that we've done things like this. And more than that, whether or not you remember that how to do them. If I asked us to solve, that's an ugly one. Maybe not. How do we solve this without writing it? Six to the third is equal to what? X is 216. We just use the definition. This base of 6 to this power equals x. Like, that's how logs work. Okay, this one. How on earth could we solve it? I'll tell you, I think that, let me think this out. I think 2 to the 9 is 512. Could I just write these both to the power of 2? Like, and 512 is a big number. You probably don't have that one just ready to go. But if we did a simpler problem, like, I don't know, any of these, 2 to the x equals 32. Can you solve that one? 2 to what power is 32? 5. So this is x equals 5. And that's a one-to-one property, right? Okay. Do we need to do a bunch of problems like that? So let's move to more interesting stuff. Cool. All right. So right off the bat then, we're just going to jump in with solving exponentials. So we're solving equations, and our first focus will be on specifically solving exponentials. Okay. Now, if you don't recall, what makes something an exponential isn't just that it has an exponent. Like x squared has an exponent, but it's not an exponential. It has to have a variable in the exponent. That's what makes it the exponential part. So without any other stuff, like we could write a little statement here where it just says, let's use all the properties that we've seen. I'm not going to write it. I'm just going to say, let's use our properties, and we'll just solve. So you know the actual directions is solve each equation and approximate if possible. I'm not going to make us approximate. I'm cool with exact answers. So here we go. Let's solve some ugly ones. All right. I want us to get an exact answer for the following. So example, solve, and we'll just say exact. Your book will likely ask for approximations. They will even tell you how many decimal places to round to. They say 3 in here. I don't like that they arbitrarily move between numbers. If I'm using decimals, it's 4 with logs or trig. All right, so here we go. Let's do our first problem together. I want to know, when is it true that 2 times 5 to the power of x, 2 times 5 to the power of x is equal to 32? Now, for these, it's going to depend on the particular problem as to like what the physical step that we do first. But when we go all the way back to algebra, if we compare the simpler examples that you've seen in like your history, whether it's pre-algebra, like middle school stuff, or in Algebra 1, how would you solve this equation? It looks very different, but there's a general rule of thumb, and we probably all use the same language, and I'm just checking it. How do we solve this? Okay, why do that? Because I agree. We're getting only x's on one side. Have you guys used language, isolate the variable? Okay, we're going to do the same thing. Between these steps, I'm just going to annotate in white, isolate x's. And I'm going to say isolate terms with x, but that's the exact same thing that we did here. Get everything with x on one side and anything that doesn't have an x connected to it somehow on the other side. What would you have me do to both sides to make it so that only things with x are on one? I'm going to divide both sides by 2. Now, when I do that, I get 5 to the power of x equals 16. And I don't know the best way to do that. I'm not going to write divide by 2 because I think it's obvious. Okay. Now, in the other problems that we'd done, and this is the one that I just said, hey, the other day, try this, and nobody could do it, which was very intentional. I cannot, for the life of me, write 16 as a power of 5. I just don't know what it is. I know it's between 1 and 2 because 16 is between 5 and 25. So it's somewhere in there, but I don't know what it is. We have something to our advantage here. And it turns out that we get a bunch of choices. I know the one that I want to use, but we'll see what we go with. We have an exponential. Do you guys agree with it? What undoes an exponential? A log. Now, There's a natural choice that one might use for the base of this. Terrible choice of words. I was not trying to lead you to any particular base, even though I said the word natural. I was not trying to. What's the base of that exponential? 5. Do you guys agree that log base 5 seems like a natural choice? Okay, that is, again, I should not use the word natural. It is not what I would do, but I'm going to. So check it out. We are now going to undo exponential using, and I'm going to do this two ways, but I'm going to do it right now the way that is the most obvious choice. Log base 5. Now, for this, we need to clean stuff up here just language-wise so that we don't get confused. The logarithm is like a whole operation. Like if I say take the square root of each side, there has to be something to take the square root of, right? So we're really just taking the logarithm of each side. So undo this using log base 5. And then if you want it, in case we need it, and it's entirely up to you, take log base 5 of, if I do it to one side of the equation, I better do it where else? Both, or the other side is the real answer. This is what I really mean by it. We're going to take the log base 5 of both sides. Now, when we do that, it means that whatever I write here, and I'm going to do log base 5, this whole side just became my argument. Log base 5 of 5 to the x. And on the other side, we have equals. And I'm going to do what to this side also? Love that. Take the log. I don't log or just multiply. We're not multiplying. We're taking the log, just like you take the square root. So here we go. I'll do the log base 5 of 16. Okay. We're just doing algebra. Same thing to both sides. We're allowed. Does anything convenient happen in this problem? Any properties that you guys know about logarithms, whether they're adding, multiplying, dividing, powering? Do we have a power? Now, there's two ways that we can view this, and I don't really mind. I don't care which way your mind envisions it. I'm going to do it one way this time. Where does the x move? Okay, so I'm just going to do that, and I'm not going to switch colors anymore. This becomes x because it moves out front. That's our log prop times log base 5 of 5. And that's still equal to log base 5 of 16. You guys agree with that? Okay, now this question, I'm going to give you the answer right now, and I'm going to ask it probably 30 times over the next couple days. This is just a number. It's just a number. It's an ugly number, but it's not this time. It could be. It's a number. That's what I care about. The fact that this is a number, we might do stuff differently on this first basic example, but if I have x times a number and I'm trying to solve for x, how do I undo x times a number? What undoes multiplying by a number? Dividing. Now on this one, again, some of you are going, no, I wouldn't do that. That's dumb because I know this number. But just for the sake of doing it, let's just say we didn't. Do you agree that this would then be log base 5 of 16 minus log base 5, or sorry, divided by log base 5 of 5? Like, and I know nobody would really do it this way. Can you tell me why you wouldn't do it this way? This is 1, and I just want to make sure that we see that it's going to be 1, and we're going to treat it like 1. But maybe there's some times when we don't know what this number is, and we just need to be able to do the same thing. Once I'm here, I have it solved for x, and I think it is worth our time to do it now. What did you guys just tell me that was? So x is equal to what? Okay. I'm going to do this problem again, but I'm going to do it the way that I would do it. I don't know what this number is. 5 to some power? No clue. Could your calculator tell you? Yeah. Now, I'm going to do the exact same problem, and I'm going to do it differently. I don't really care what base we use. Doesn't matter. As long as I use the same base on both sides. Like 5 worked nicely because it turned to 1, right? But I'm going to try this differently. And I'm just going to jump in on this step. Instead of log base 5, any gut feeling what log I would rather use? What's easier to write and takes less time? Log base 10 is easier. What's easier than writing 3 letters? ln. If I jumped in like this, and it feels like a random choice, right? Because 5 is obvious with the base, but I just want to see what happens here. Where does this exponent move? So we get this instead, x ln 5 equals ln of 16. And now this part makes way more sense, but we're going to treat it the same. This is x times a what? It's not a 1, not in this case, because I didn't do base 5. Does anybody know what this is off the top of your head? Me neither, but can we all agree that it's just it's a number. We have x times a number. How do I undo that? I'm going to divide by that number, just like we did before. This is where I wind up. Our answers look wildly different, right? Do me a favor, though. Turn back your notes till you see change of base. It's probably one page back. Change of base says if I wanted to evaluate this, what number is top and bottom in these two? Like, and I know that's a weird question, but physically on the page, which one's higher and which one's lower? This is higher, right? So the change of base says, as long as the bases match, we can do the following. I could rewrite this as the natural log or whatever log of 16 over the natural log of, and now we see we do get the same answer. It's the exact same answer. Addison.
I see what you're saying about the change of base, but how do you know that you can just change it to ln instead of base 5?
So we can change it as long as the base matches. We did not prove it. So as long as whatever this, like I could have done this and I chose this to see that they're the same, but it really doesn't matter. If I had chosen here to do log base 10 instead, like just by choice, then my argument here would have been, oh yeah, well this is just log base 10 of 16 over log of 5. Like, and I would have just changed it to match. And I'm just convincing us that it's the same number. It doesn't matter if we use the base that's written here necessarily. Sorry, here. It's nice because we get a 1 out of the deal. But if we're getting exact answers, I don't really care if I get a 1 or not. This is easier and it will always work. Okay. Did that really clear it up? Yeah. I didn't feel like I answered it, but I'm glad. Okay. Do you guys prefer whether we do log base 5 in this situation or if we use ln? No preference? Okay. We'll do a bunch more of these tomorrow.
Yeah.
Yes. Your quiz takes priority, just so you know. Cool. Going to Safeway with your friends might not, but it's also your choice. Cool.